Hello and welcome to the first GCSE Engineering AQA video of the Novel GCSE series. In this video, we're going to be going over the massive subtopic of systems. Now, the reason why I'm doing these series is because there are not many of these resources online. Now, another point here, this video will also be suitable for the design technology specification as well. If you find this video helpful, then don't forget to subscribe, like, and share this resource with your friends. Topic 3, systems. So a system is a collection of parts, subsystems, and components, and they all work together to achieve an outcome or a function. Now, systems can be represented by what we call a block diagram. So block diagrams are used to represent systems. Now, in this case, block diagrams are used to represent the three key components of any system. You have the input, the process, and the output. Now, you would be familiar if you've studied computer science with this. So the input takes a real-world signal and converts that into a signal that the processor would understand. For example, if it was electric current signal or voltage. Now, the processor will apply a change to this signal, and then the output would convert this changed signal into a real-world signal again. So an example is an outdoor security light sensor. So this block diagram shows that when it is dark, the light sensor would detect this. It will then convert this signal into a signal that the processor, the timer, would understand. And in this case, the timer is a subsystem. The timer will then turn on the LED for a set period of time, outputting its process to the output, the LED. Now, a common mistake when designing systems is the assumption that systems can only have one input or one output. But in reality, a system can incorporate several different inputs and several different outputs. For example, you can see the block diagram for a burglar alarm here. So in this case, there are multiple different motion sensors around a home. And if any one of them detects this signal of movement, it then sends this signal to the processor, which in this case is a microcontroller. The microcontroller then decides to activate the alarm, and this is then activated via the outputs, the siren, which makes an audio noise, and a flashing LED, which is the light. So these are the different outputs. So in this case, the microcontroller is known as the main control device. Now, you've also got what is called a schematic. So a schematic is basically a circuit drawing. It shows the individual circuit components and how they are connected together. Now, this all uses circuit symbols. Now, circuit symbols represent individual components, and circuit symbols are agreed standards. For example, it's agreed that a bulb uses the circuit symbol on the left, and it's agreed that a resistor uses the circuit symbol on the right. And that means that anybody who knows these circuit symbols will be able to follow the path of a schematic. Now, flowcharts show the sequence of events, and a key thing here is it shows the order of different processes. An example of where flowcharts could be used is a manufacturing process's different stages, or how quality control procedures are applied. Now, you can see the different drawings of the flowchart components. So you've got the terminator, which is the start or the stop. You've got the input or output, the process, and the decision. Now, just some more points about a schematic is that when you are drawing a schematic, the best thing to do is to label each component. Now, not just with the type of component, but also if there are multiple of that component, number it. So give them different numbers, the first one, the second one, the third one. Another thing is that when we're referring to a circuit diagram, that means we're referring to an electronic schematic. And a general schematic diagram can be used for anything, but a electronic schematic drawing is known as that circuit diagram. So let's talk about linkages now. So linkages are basically these rods that are connected together via pivots. Now, they're an example of a mechanical system because they actually either change the size of a force, change the direction of a force, or they can even change the type of force as well. So that's changing the input from the real world signal to a different output. Now you can see I've put 3 different types of linkages here. So you've got the reverse linkage, which contains 3 rods, and the middle rod has got 2 moving pivots. Now these 2 moving pivots enable the input force going to the right to be changed into the output force moving towards the left. So the reverse linkage allows you to change your direction. Now looking at the parallel linkage. So with the parallel linkage, what you're doing is you are putting your input force towards the right hand side, and because of the fixed pivots, it causes the output force to do it in the same direction. Now the whole purpose of the parallel is to connect the linkages in the same direction. And then you've got the bell crank. So the bell crank is a bit of a staircase shape. So you've got your input going towards the left-hand side, and then this causes your output to actually go downwards. So what it's doing is it's changing horizontal motion into vertical motion. So if you move to the left, you will go down. If you move to the right, you will go up. Now you also need to know a little bit about mechanical advantage. So the mechanical advantage, as you can see in this little picture, is the ability to move a large load with a very small effort and a small input force. So in linkages and other mechanical systems, it's just the output force over the input force. But generally speaking, mechanical advantage is the load over the effort. One of the main functions of mechanical systems is to convert motion. So this means turning one type of motion into another. Now, firstly, the thing you need to know are the 4 different types of motion. So you've got linear, which is moving in a straight line, rotary, which is moving in a circular pattern, reciprocating, which is moving in a straight line back and forth, and oscillating, which is almost swinging from one direction, from one point to another and back. Now, there are 3 different examples of the conversions of motion that would be helpful to know for GCSE Engineering. So the first one being the rack and pinion. So the rack and pinion is a conversion of the rotary motion of the pinion to the linear movement and motion of the rack. So the rack is just this flat bar rod which acts as a gear because of the teeth, and this teeth combines with the teeth of the pinion, which is a circular, more obvious looking gear, and it causes the rotary motion. So as the gear rotates, it causes the rack to move in a straight line, either forwards or backwards. Now let's look at the crank and slider. So the crank and slider mechanism is used to convert the rotary motion of the crank into the reciprocating motion of the slider. So what happens is as the crank moves, the rod, which is following a point on the crank, it moves with it, and it moves in the different directions as it gets further and as it gets closer. And this then causes the slider to move in reciprocating motion. Then you have the final one, which is the cam and the follower. So the cam and the follower is another method to convert the rotary motion of something into the reciprocating motion. So what happens is you have the follower, and as suggested by the name, the follower follows the surface of the cam. So unlike the crank and slider, in which the slider followed the rod, the slider followed the rod and the rod followed a point on the crank, the cam is followed on the surface by the follower. Now the cam can be any different shape, and an eccentric cam is when the centre is not in the centre, and what happens is as the cam moves, the follower also moves because it's moving in the different directions, the different radiuses, and this causes the reciprocating motion to happen. Let's look at gear trains. So gear trains are used to transmit rotary motion because it's moving in circular motions. And sometimes this rotary motion, or this turning effect, is referred to as torque, Torque. But do not get confused, they're just referring to the turning effect. Now, you need to know that when there's a larger gear driving a smaller gear, then this will cause an increased speed but a decreased torque. But if you were to have a smaller gear driving a larger gear, that would result in a decreased speed but an increased torque. Now you can see an example of a gear train in front of you here. And a key thing to know about this is gear ratio. So they might ask you to calculate about gear ratio. And all you would have to do is count the number of teeth on the driven gear, so that's the gear that's being moved, and divide that by the number of teeth on the driver gear, so the gear that's moving it on the left-hand side. Now you also have an alternative to the gear trains, which is called a chain and sprocket mechanism that you can see on the screen now. So why it is an alternative is because instead of just having the gears moving another gear, you have another part of this, which is a chain. And the chain is just acting as a linkage. So it's got the little pins in it with the different rods. And what happens is the sprockets are toothed wheels. And these sprockets, which look like gears, the chain fits over the sprockets and then allows a distance. So what happens is as the sprockets move, the chain moves, and the chain then allows the smaller driven gear to be moved. And the advantage of this is that for something like a gear train, if you wanted to have a gear on the left hand side move another gear that was 5 meters away, you would have to have loads of gears in between. Whereas with a chain and sprocket, you could just use a chain that was 5 meters long and still have only 2 gears or 2 sprockets needed. Pulleys are commonly used to lift heavy objects by reducing the effort. A pulley with mechanical advantage of 2 can be used to half the force. Now we also have mechanical parts called bearings. Now the purpose of bearings is to control motion and reduce friction between moving parts. So you have a plain bearing, and plain bearings provide a sliding contact between the parts of a machine. A rolling element bearing provides balls or roller bearings, which are spherical cylinders or spheres that move between 2 bearings to prevent any friction from building up. Moving on to electrical systems. So the first thing in the top left of the board is all about current. Now, current is just the flow of electric charge through a conductive medium. For example, the flow of electric charge through a wire. Sometimes it's referred to as the rate of flow of electrons, and either is accepted, but I think the examiners would prefer the flow of charge through a conductive medium. Now, there are 2 different types of current. You've got alternating current and direct current. Alternating current is constantly changing direction because of the alternating voltage, and direct current stays in the same direction. Now you can see in these 2 graphs that with alternating current it's oscillating, and it's got a differing amplitude, whereas with the direct current graph, it's just a straight line, but also note that the y-axis is not the amplitude in this case, the y-axis is the voltage. Now, there are also devices used to convert alternating current supply into direct current and direct current into alternating current. And this process is called rectification. So an example of this is a USB cable, which you can see I have put up there. So a USB cable is used to get the direct current of a battery, and in order to recharge it, then you have to connect that to the mains supply, which is alternating current. So in that way, you're transferring the alternating current of the main supply into the direct current of the battery. And this is what happens when you're charging a phone or a laptop battery. Now, the next thing you need to know is just a quick equation that voltage is equal to current times resistance. Now, you will use this principle more in topic 4, but it's still relevant when we're talking about current in electrical systems. Now, in order to get access to the mains electricity in the UK, which runs at 230 volts, you are going to need something called a 3-pronged plug, which you've clearly seen if you've got access to electricity, which most of you have. Now, what this has is 3 connections, 3 prongs, which are connected to the live, the neutral, and the live wire. And each of these 3 work together to get that mains electricity out. Now, there's advantages and disadvantages to the mains electricity. First of all, you need to know that's a type of alternating current, which we already discussed. Now, advantages is that it's cheap, and in the UK it's readily available. However, disadvantages is that if you were to go into contact with the live wire or the live parts, then you could be in danger of receiving an electric shock. And if there was also faulty equipment, then that could also cause it to burst into flames or to even cause an explosion altogether. Now let's look at batteries. So mains electricity was alternating current. Batteries are direct current. And they're just the circuit symbol of two cells put together with this dashed line in between them. Now, in every battery, there are two terminals, the anode and the cathode, and you also have the electrolyte between them. Now, batteries, there are different types of batteries. So you've got the single-use batteries, which once one of the electrodes are complete, then you throw them away. Or you've got reusable batteries, which can be recharged by connecting it up with the alternating current supply. And now we looked at how in systems there are input and output devices. So let's look at some of them. So in terms of the input devices, you have either the switch or a relay. Now, a switch is used to control the current and allow current to flow through if it's closed, and stops current from flowing through if it's open. Now, relays work in a similar way, but they are basically an electrically operated switch, which allows you to switch to a large loaded current from a small current that's controlled. Now, output devices include things like motors and solenoids, and then buzzers and bells and lamps. So think of the sensors here. For motors and solenoids, this allows movement. And motors use electrical signals to convert these electrical signals into rotary motion. And solenoids use electromagnetism to be converted into either linear or rotary motion. Now, when we're talking about buzzers and bells, this is used to produce sound. So buzzers use an internal oscillator, which is used to create sound, and that sound frequency will be the same as the frequency of the current. And then a bell has a circuit symbol of just the opposite, almost the reflection of a buzzer that's smaller. And bells use a electromagnet in order to generate sound. Finally, output devices of lamps. So lamps are output devices that create light. Now, you've got the symbol of the lamp there, and it's normally a filament lamp, so that's the filament lamp symbol, and you've got this filament wire which heats up, and as it heats up it emits light, and that's used as an output device for an electrical system. Now looking at inputs and processes. So the first thing you need to know are the signals. So there are analog signals and there are digital signals, and normally in a block diagram in a system, these are represented by the arrows. So an analog system can take any value firstly, and it also changes continuously. So it could be something like the light levels where it could change. Now you can see the graph which goes up and down. Whereas a digital signal can only take one of two values, 0 or 1. And it travels as pulses of information, each of the signals. And that's where you can see it's represented via the bar chart above. Now, looking at inputs, a key type of inputs are sensor inputs. Now, they allow you to gather information from the environment and then decide on sending this to the processor. So sensors can be analog or digital, and there are two main ones that you need to know about. So you've got the light dependent resistor, which depended on the light intensity causes a signal to happen, and because of the resistance, so the resistance decreases as the brightness increases, and thermistors change the temperature. So as the temperature increases, the resistance decreases. Then you have process devices. So these respond to the electrical signals and cause the signal to change before giving them to the output. So the first thing is timer circuits, which are used to turn an output on or off depending on a certain amount of time in response to an input signal. Now you've got counters, which count the number of times an event happens, and this may be triggered by switching or pressing a circuit. And now looking at comparator circuits. So comparator circuits use a special device called an operational amplifier, and this operational amplifier is also shortened sometimes to an op-amp. Now this is used to decide which of the two input voltage signals is greater, and then it takes that information and indicates and is indicative in the output devices such as an LED, a lamp, or a buzzer. Then finally you have logic gates, which are not, which means it outputs the opposite of the value, and which means you need both to have 1 in order to output 1, and OR, which means either the 1 or the 0 needs to be outputted to output OR. So now moving on to programmable devices. Now programmable devices are used to perform either complex operations or, just like the operations we've looked at, things like timing, counting, and comparing signals. Now a commonly type of use of a programmable device, a microcontroller, is a PIC. But first let's look at what is a microcontroller. So a microcontroller is a small computer that is found in an integrated circuit. It has loads of different pins and ports, which allows it to easily connect to the input and output devices, and multiple of them. So a PIC is a type of microcontroller. It stands for Peripheral Interface Controller, and it tends to be used for GCSE level between 8 to 14 pins, because we don't tend to, at GCSE, use too many inputs or outputs, but it can travel all the way to 40 pins. Now, unfortunately, peripheral interface controllers and microcontrollers in general only understand digital. So digital signals, meaning ones or zeros, and they do not understand analog. So most microcontrollers therefore have to have a built-in analog to digital converter so that the microcontroller could understand what you were talking about. You also need to know some advantages and disadvantages for these programmable devices, these microcontrollers, these PIC ones. So advantages is that it's flexible and adaptable, and the reason why is because it can be reprogrammed for loads of different functions, whereas instead of just being single use. Another advantage is that they can actually replace loads of different components by performing complex operations that add up to all of these ones. So you don't need these extra components when it can all do one job in one component. And finally, it can also really well manage multiple inputs because of the multiple different pins and ports. Disadvantages, however, it can be expensive, and it also requires software and hardware that understands and works with that programming language that it uses. Moving on to how we actually program these devices to work. So in terms of the PIC can be programmed via 3 ways. So using a block-based editor, and this is what most GCSE engineering students do in their coursework. They use a block-based editor, and this is used to put blocks together, and this can then be translated onto the microcontroller itself. You can also use a text-based program, so using something like Python or JavaScript to physically write it out and then connect it, or you could use flowchart software in which each of the stages will then be converted into the microcontroller. Now moving on to the left corner of the board, which is all about transistors and drivers. So firstly, what is a driver? A driver is a component that boosts the output signal. And this is because certain components need a larger current than the microcontroller would produce, because microcontrollers tend to produce a small current, and this needs to be up-leveled and boosted between the process and the output. The first example of a driver is a transistor. Now this boosts small current to medium current for components like lamps or buzzers. Now, transistors are 3-legged, so they have 3 components. You have the base, you have the collector, and you have the emitter. Now you also have field effect transistors. Now this boosts the voltage. It's a voltage amplifier. And it's also three-legged, but it's different components. So you've got the gate, the drain, and the source. Now, the last little bit of information which we haven't covered is about program monitoring. And program monitoring is needed for ensuring that it's safe, it's consistent, and it's economically viable. Now, as well as those devices, we also need to know about output and passive devices. So output devices converts the electrical signal into a real-world signal, and the passive device does the same, but it does not use any source of energy. Now, with output devices, there are three you need to know. Firstly, LEDs, light emitting diodes. Now, these produce light when current flows through them. And you can see that there are two legs. The longer leg is the anode and the shorter leg is the cathode. So when current flows through the anode to the cathode, that is when light is produced. You can see the circuit symbol there, which is a triangle and a line and outputting two arrows. Now, also with an LED, sometimes you may need a protective resistor in series, and this protective resistor will control the amount of current, because if there's too much current, an LED can break its fuse. Now, the next one is a 7-segment display. This is a collection of LEDs which is used to represent the numbers 0 to 9. You might have a clock which looks like this. And finally, you have the piezo sounders. And the piezo sounders work on turning the electric signal into sound with different tones using the piezoelectric effect. And this is actually more effective than using something like a buzzer because it's more accurate to the sound. Now moving on to the passive devices. So firstly, resistors. Now resistors work to decrease the current and it's measured in ohms. There's two types of resistors. You've got the fixed resistor, which is set at a value within a percentage tolerance. And in order to get a total resistance, then you need to include multiple resistances in series. And then you've got the variable resistor, and the variable resistor can adjust its resistance. And you can see this in LDRs when it adjusts its resistance based on the light intensity, and thermistors when it adjusts its resistance based on the temperature. Then you've got diodes. Now, diodes only allow current to flow in one direction from the anode to the cathode, because in the other direction, there's very, very high resistance. Now, diodes can also be used in rectifying currents. We talked about the process of rectification, where you're getting the AC supply from the mains to the DC supply of the rechargeable battery in your phone. And a certain type of diode, a power diode, is integral in this. Then you finally have capacitors. Now, capacitors' roles are to store charge, and it's measured using the unit farads. Now, there's two types, there's polarized and non-polarized. So with polarized, it has to be the correct way around, whereas non-polarized, it doesn't matter. So when looking at structural systems, you first need to look at what loads are and what stresses are. So loads are the forces that place stress on a structure. Now, there are two different types of loads. There's a static load, which is referred to as a dead load because it doesn't move. For example, the weight of a building. Or you can have a dynamic load, which is a live load. For example, if you have a bridge and the movement of cars on the bridge, it's moving, or the movement of wind. Now, let's look at stress. So you can have two main forms of stress that affects the structural system. So tensile stress, which is the pulling and stretching, and this results in elongated structures. And then you have the compressive strength, which is pushing it together, and this can result in the structure buckling. Now, you also need to know about torsional, although it doesn't really affect structural systems. This is the twisting. Now, if you include both tensile and compressive, then it can result in bending. Now, structural failure is when a structure is stressed beyond its limits. It's stressed beyond its capability, and then massive things and massive repercussions could happen. For example, if a bridge is experiencing stress beyond its limits, it could collapse, and that could be really damaging. And that's why you can prevent these stresses through structural analysis. And this is through those experts doing calculations and modelling. Now, let's look at space frame structure and the monocoque structure. So the space frame structure is when you have these struts that are locked together in a geometric pattern. Now these are ideal for public spaces because they span really large spaces and you don't have to have many material because it's obviously mainly see-through. Then you have the monocoque structure. Now this is more used as a necessity. So this is when you have an external skin to support the load inside. For example, in a plane, you have that external skin, and the purpose of this is that there's no weak points. It's quite stiff, so it avoids tension in tensile stress. And, however, a disadvantage is that it's subject to breaking. Now, the monocoque structure doesn't have any internal structures, it just relies on the skin, whereas a semi-monocoque structure uses both a skin and a structure. Now, you may also need to know about pneumatic and hydraulic systems. So, a hydraulic system relies on liquids to work, and a pneumatic system relies on air and compressible gases. Now you may be asked to compare pneumatic and hydraulic systems. So pneumatic systems are faster because there is a faster flow of air in comparison to liquids, and also there's a less resistance path for air as compared to liquids. Another issue with hydraulic power and hydraulic systems is that when there are faulty valves, this means that the liquid could escape and stop working, whereas this doesn't necessarily happen for pneumatic systems. However, a disadvantage with pneumatic systems is that they produce less of a force and hydraulic produces more of a force. And another disadvantage is that with pneumatic systems, you first have to require the process of recompressing the gases instead of the hydraulic system where the liquid is already prevalent and easy to use, so compressing the gases is an expensive process. Now, another thing you will need to know is how pneumatic systems work. So a key component of pneumatic systems are cylinders. These produce motion by moving a piston. So as you can see, there are two different types. There's the single acting cylinder, which produces linear motion because what happens is the pneumatic pressure creates a force of linear motion that only acts in one direction, which is normally outwards. Now, double acting cylinders can create reciprocating motion because they can extend and retract using pneumatic pressure, which means they produce reciprocating. This is done in two ports, so they bring in air from the outward motion and the inward motion. Key equation you need to know is that force is equal to pressure times area, and this will normally be used when you're talking about cylinders and if there was a question on cylinders. Now you need to look at delay circuits and logic circuits. So purpose of delay circuits is when you use a unidirectional flow control valve to fill up a reservoir. Now as it fills up the reservoir obviously ends up getting full up, and this then cuts off the unidirectional flow control valve. Now as it cuts it off, this then causes a time delay, and this time delay will be useful. Then you have logic circuits. So logic circuits, there are and or. So and are used for series circuits, and both values need to be pressed in order for the cylinder to be operated, whereas in the or logic circuit, then only one of them needs to be pressed, but it works in a parallel. And finally, applications of pneumatic systems. So pneumatic systems can be used when needing a high speed and high accuracy. For example, robot arms movements, automated assembly tools, or power-assisted construction tools like a pneumatic drill.